So the next topic is converting a binary number to a decimal number. So in the previous topic about the introduction of the binary system, you have already an idea how to use the two symbols 0 and 1. So now we are going to continue in converting binary number to a decimal number. So I will give you 5 examples how to convert binary number to a decimal number. So we have here the instruction. Write the decimal number represented by the given binary number. So the first question, or the first problem rather, is 1100. So do not forget that the base system will always start with 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, and so on. Okay, so I think you should try to remember this base form because it will help us later when we are going to convert binary numbers to decimal form. So the first question or the first problem is 1100. So we are always going to start in the least part, the least position, or the least value. So we have 0, so you have to write it here, 0. Okay, can you see that? 0, 0, 1, and 1. There you go. So when it comes to converting binary digit to decimal form, you have to multiply this one. So 0 times this one, 2 to the power of 0, 0 times 2 to the power of 1, 1 times 2 to the power of 2, 1 times 2 to the power of 3. Okay, so let's go ahead and try to solve this digits. So 2 to the power of 0 is 1, so therefore this one is 0 times 1, that would be equals to 0. Okay, so in this part is equals to 0 times 2 to the power of 1 is equals to 2, so 0 times 2 is equals to 0. The next, let's continue. We have 1, so that would be 1 times 2 to the power of 2, that would be equals to 4. So 1 times 4 is equals to 4. And the next, the last one, that would be 1 times, so find the value of this exponent, 2 to the power of 3, so that will be 2 times 2 is 4, 4 times 2 is 8. So 1 times 8 is equals to 8. And after that, once you already calculated, you have to add the decimal form. So we have, this one is 0, 0, so 4 plus 8, that will be equals to 12. So the answer, I'll just put a line here. There you go. Okay, so I'll just write here answer. So that will be equals to 12. Okay, so therefore this number 1 example is 1100 is equals to 12 in decimal number. Answer. Okay, So let's proceed to number 2. Number 2 example is sorry, yeah, that's correct. The second example is 1 0 0 1 0. So the same method. So you can create a table because I think it is more organized and easy to understand. Okay, easy to understand. Okay, so you know what you're doing, so it's very important also. But later on I will provide another example which is a different way how to convert binary digit to decimal form, which is we do not need to create a table rather, but instead we just write them all in one equation. Okay, so this one is the decimal form. Okay, can you see that? Okay, there you go. So always remember that you always start at the least value, so you have to write 0 1, this one 0 1 0 0 1. So the same method, multiply times 2 to the power of 0, 1 times 2 to the power of 1, 0 times 2 to the power of 2, 0 times 2 to the power of 3, 1 times 2 to the power of 4. There you go. Okay, so let's calculate this equation. So this one is 0 times 2 to the power of 0 is 1, so that will be 0 times 1. That will be equals to 0. So you have to write 0. Next, 1 times 2 to the power of 1, that will be 2. So 1 times 2, that would be equals to 2. Next, 0 times 2 to the power of 2, that would be 4. So 0 times 4 is equals to 4. Is equals to 0. Next, continue. 0 times 2 to the power of 3, that will be 2 times 2 is 4. 4 times 2 is 8. So 0 times 8, that will be equals to 0. Okay. The last one is 1 times 2 to the power of 4. So that would be 16. Okay, so 1 times 16 is equals to 16. So we're done calculating the binary digits. So we can have another line here, another row for our final answer. There you go. So I just have to write here answer. Okay, there you go. So add the decimal form, so that will be, we don't need 0, it doesn't affect the value. So 2 plus 16, that would be 18. There you go. So therefore the binary number 10010 is equals to 18. So this one is equals to 18. Answer. Okay, I'll give you 2 minutes to look at the lecture. Then we can proceed to number 3, or the 3I example. Okay, so let's move on to number 3I example. So just, sorry about that. Let's remove this one first. Okay. The third example, which is the 3I. So we have 1 1 1 1 1 1. Okay, so we have 6 1. So the same method, we apply the table, okay? Binary digit. Okay, now the reason why I use the table, because I think it's the easiest way to explain on how to convert binary number to a decimal number. Okay, so let's proceed to our lesson. Okay, there you go. Hold on a second. There you go. Sorry about that. So this one will be our decimal form. Okay. So this one is very easy, I think, because we got 1-0. So start from here as well. So that will be 1, 1, 1, 1, 1, 1. So how many 1? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay. So since it's binary, this is a method. We use the base 2 form. So that will be 2 to the power of 0. 1 times 2 to the power of 1. 1 times 2 to the power of 2. 1 times 2 to the power of 3. 1 times 2 to the power of 4. 1 times 2 to the power of 5. So let's calculate. Let's solve this. So this one, 1 times 2 to the power of 0 is 1. So that will be 1 times 1 is 1. Okay. The next one, that will be 1 times 2 to the power of 1 will be the same, 2. So 1 times 2 is equal to 2. Next, 1 times 2 to the power of 2, that will be equals to 4. So 1 times 4 is 4. 1 times 2 to the power of 3, that would be 8. So 1 times 8 is 8. The next one is 1 times 2 to the power of 4. That would be how much? 16. So this one will be equals to 16. The last one, 1 times 2 to the power of 5. So 16 times 2, that will be equals to 32. So this one is 32. Oops. We have to extend our lines. It's not enough. Okay. Okay, there you go. There you go. Okay, so I'll just write here the answer. Okay, and after that we add them. Okay, so it means adding or plus. So 1 plus 2, 3. So 3 plus 4, and then 4 plus 8 plus 16 plus 32. So you will come up with 63. Okay, so that's the answer for our example number 3. So therefore, no, I'll just put here, no? Therefore, it's better. There you go. This in English is therefore. I think in Pasa Thai is dangnan. So therefore, sorry, the binary digits 1, 1, 1, 1, 1, 1 is equals to 63. Answer. Okay. There you go. So if you having a difficulty in understanding, you can ask me questions. Like you can send me a message, a private message. So I'll be more than happy to help you. So let's proceed to our 4th example. So that would be in Roman numeral IV. So that will be 4. Okay. So in this 4th example, I am not going to use the table. Rather, I'll just write them in one line. So let's write first the question. So the question or the problem is 1, 0, 0, 0, 1, 0. Okay, 1, 0, 0, 0, 1, 0. Okay, so in this fourth example, the method is, the way it is being written, or the solution is totally different. Okay, because in the table we started from the least, but in this fourth example we are going to start in this one. So I'm gonna write solution, SOL. Okay, the abbreviation for solution. So I'll just go ahead and write again the question. That will be 1 0 0 0 1 0 is equals 2. So that will be 1. So I'm gonna write 1 times. So I'm gonna use 2 the same because it is a binary, so the base is always 2. 2 to the power of what? So the question there is what power you are going to put it here. Do you think it's 0, or do you think it's 4 or 5? So what you have to do is you can count it here on the problem. So this one is 2 to the power of 0, 1 2 3 4 5. So therefore this is 2 to the power of 5, and the sign plus because we need to add them after we calculated this part, so like this one. Next, 0 0 times 2 to the power of 4. Okay, so it's getting lower, the power or the exponent is getting lower. So 0 times 2 to the power of 4 plus, there you go, 0 again. So that will be 0 times 2 to the power of 3 plus 0 again. So we're done with this one. Done. So 1 0 0 and another 0. So 0 times 2 to the power of 2 plus, done. So next with 1, so 1 times 2 to the power of 1 plus 0 times 2 to the power of 0. That's it. So let's try to solve them. Let's calculate them. So this part first, so this portion first. Okay, this part first. So 2 to the power of 5. So 2 to the power of 5, that would be 32, right? So 2 to the power of 5 is 32 plus, 2 to the power of 5 is 32 times 1, so that would be 32. Copy the sign plus. So this one is very easy because no matter no matter the value in this part, in the exponent, when you multiply it to 0, that will come up with 0. Okay, copy the sign again plus. So the same manner, since we are going to multiply it with 0, you will get 0 plus, and of course this the same, 2 to the power of this 4, but times 0 is equals to 0. There you go. Next, in this part, okay, we are here now, so you can follow. Okay, 2 to the power of 1 is 2 times 1, that would be 2 plus 2 to the power of 0 is 1, but times 0 is equals to 0. Okay, not yet done. There you go. So after that, we can now add them. So 32 plus 2, that will be 34. So the answer is 34. Okay, so therefore, it's gonna put it here. The binary 1 0 0 0 1 0 is equals to 34. Answer. there you go. So it's very easy as long as you can understand the basic knowledge about binary, and I think you are good to go. Okay, so let's move on to the last example. Okay, so the last example, let's go ahead and continue. So the last example is a V with a Roman numeral V or 5. So I'm gonna write here V. So the problem is 1 1 1 0 0 1 1. Okay, so let's go ahead and continue. Okay, I'm gonna write solution for our problem. So that'll be 1 1 1 0 0 1 1. That'll be equals to. Okay, so the same method in number 4 example. So we are going to start here. So that'll be 1 times 2. So what will be our exponent? So that is the question there. Make it sure that you understand the pattern. So this is 0 1 2 3 4 5 6. So this is 2 to the power of 6. Okay, 2 to the power of 6. Then continue, plus sign. 1 times 2 to the power of 5 plus 1 times 2 to the power of 4 plus, so we are 0 0 times 2 to the power of 3 plus. Next, 0 0 times 2 to the power of 2 plus. Next, 1 times 2 to the power of 1, plus, and the last 1 times 2 to the power of 0. Okay, well, actually this symbol parenthesis, this one and this one, it denotes a multiplication or times already. However, I just write the sign, the mathematical operation, which is times or multiplication, so that it will be more easier for you to understand it. Okay, so let's continue. Okay, there you go. So we are going to find the value first of 2 to the power of 6. So 2 to the power of 6, that will be how much? Can you help me? How much is that? Okay, so that will be 64. Okay, so you can write 64. So I'm just gonna write here 64, because 64 times 1 is the same, 64, plus 2 to the power of 5, that would be equals to 32. So 32 times 1, that will be the same value, 32. There you go. Plus, so I'm gonna go ahead and check this one. Check means we're done. Okay. So next, 2 to the power of 4, that would be 16. 16 times 1, that will be 16 as well. Okay, next. Okay, we're done with, so we'll check that. Plus this one, 2 to the power 3 times 0 is equals to 0. Check. Plus 2 to the power 2 times 0, that will be 0. So check. Plus 2 to the power 1 times 1, that will be equals to 2. Plus 2 to the power, oh sorry, we checked this one. Sorry. 2 to the power of 0 is 1, so 1 times 1, that will be equals to 1. And then we are not yet finished. Okay, so let's go ahead and continue. So what we have is we will add these values. Okay, so 64 plus 32, so that would be how much? 4, 5, 6, so that would be 6, 7, 8, 96. Okay, so 96 plus 16. Okay, so 96 plus 16, how much is that? So you can try also to calculate on your own. So that will be 112. Yes, I'm pretty sure about that. It's 112. 112 plus 2, that will be 114. Yes, that's correct. 114. And 114 plus 1, that will be equals to 115. So 115. So the final answer, therefore, or dangnan, 111,0,011 is equals to 115 in decimal number. Okay, so we're done, and I already uploaded the quiz online, so if you think you are confident enough and you understand already the topic, you can go ahead and answer it online. Okay, so please do not forget to click subscribe button on my channel. Okay,